month. So I'm going to show you some sites that you should be able to get out and have a look for yourself with a pair of binoculars or a small telescope, or even just the naked eye, if that is all that you've got. So let's draw the curtains and get going. Okay, so here we have the sky above our heads as at now. The middle of the chart is directly over our head, and obviously the edges of the circle are the horizon. We will start over in the west, because as the stars are rotating from west to east, as the Earth is rotating from west to east, the stars rise in the east and set in the west. So whatever is in the west is going to set on us reasonably quickly. So we'll investigate that part of the sky first. So let's just zoom in on the western part of the sky. And if you do have a clear sky tonight, unlike me here in the Adelaide Hills, where it's completely overcast, but if I could go out there and look up in the west, I'd be able to see the two planets, Jupiter and Saturn, quite close together, within the bounds of the constellation of Sagittarius, the Archer. We'll talk more about Jupiter and Saturn a little bit further down in the presentation. So let's just do a walk around the sky at the moment. You can see here the asterism that we know as the teapot. Right here, here's the lid of the teapot. There's the body, there's a spout, and there's a handle there. And usually when I'm showing people this out in the open sky, and you can see the Milky Way, I'll tell them that the Milky Way is a steam coming out of the teapot. Let's move around towards the southwest, and we can just see the tail of Scorpius the Scorpion here starting to set. One of the things that always reminds me that summer is definitely coming is when we've got Scorpius setting in the west-southwest, and then as we go over to the eastern side, we got the constellation of Orion, the mighty hunter, coming up in the east. Let's just come back here towards the southwest. So we've got Scorpius there, slightly already setting. As we move further towards the south, the two pointers in the sky, Alpha and Beta Centauri. Unless you've got a clear horizon, very soon you may not be able to see these as they get lost in behind buildings and hills or trees, because they do get quite low in the sky. And to the left of the pointers, we've got the Southern Cross, the very famous Southern Cross, one of the smallest constellations in the sky, but per square degree, it's got the greatest number of bright stars in it. Completely unmistakable. It's really easy to see the Southern Cross. And these two guys here, Alpha and Beta Centauri, are called the pointers because as the sky rotates around the south celestial pole here, all of these stars rotate around here like this. So the pointers appear to always chase the Southern Cross. So they're called the pointers. Now, these two stars, Alpha and Beta Centauri, if you do go outside and get to see them, you would notice that one is slightly dimmer than the other. You can see that the circle here for Beta Centauri is slightly smaller than the one for Alpha, which means that Alpha is a brighter star. By the way, all the constellations, the stars within a constellation, are named in order of brightness using the Greek alphabet. So Alpha, being the very first letter of the alphabet, means that Alpha Centauri is the brightest star in Centaurus, and Beta is the second brightest star in Centaurus. Now, these two, when you look at them visually outside, out in the dark, they do look slightly dimmer, but Not by much. Alpha is the closest star to us other than our own sun. So if I was to point a laser pointer at Alpha Centauri and there was nothing to stop that laser on its travels to Alpha Centauri, it would take just over 4 years traveling at the speed of light, which is 150,000 kilometers. No, sorry, 300,000 kilometers per second. Now, Beta, being slightly fainter, you would think that it is only slightly further away. Nothing could be further from the truth, because Beta Centauri is almost 900 light years away. So it's over 200 times further away. So really that tells us that Beta Centauri in real life is the much brighter, much hotter star. And in actual fact, that's exactly what it is. Beta Centauri is a bluish white star with a surface temperature of around about 35,000 degrees, whereas Alpha Centauri is actually almost a twin of our own sun. So it's got a surface temperature of about 4,000 to 5,000 degrees. The other interesting thing that you will find of the pointers of Alpha Centauri, if you do point a telescope to it, is that all of a sudden it becomes two stars. Alpha Centauri is actually made up of two stars that rotate around each other once every 80 years or so. And the two stars are separated by about the same distance that separates the sun and the planet Neptune. Gorgeous view in a telescope. It looks like two big car headlights coming towards you on a dark night. Recommend that you, when you get the chance to look through a telescope, have a look at Alpha Centauri, closest star to us other than our own sun. As we move around the east of the southern sky towards the east, another star that always reminds me that summer is coming is Canopus, the second brightest star in the sky. It's around about 130 light years away. Again, a big white bluish star, unmissable. Very easy to find in the sky. This part of the sky in the southeast is devoid of real bright stars, so Canopus really stands out. These two little patches that we see here, the large and small Magellanic Clouds, we'll talk about those a little bit later on in the presentation, as well as this object here labelled 104. We'll talk about those a little later. As we head towards the east, we come across Sirius. Sirius is the brightest star in the night sky. I usually trick people when I ask them, can you tell me what the brightest star in the sky is? And they never mention the sun. They always say it's Sirius. Of course, the brightest star in our sky is the sun, but in our evening sky, or morning sky, depending on the season, it is Sirius. Sirius is around about 9 light years away. So my laser pointer would be traveling at 300,000 kilometers an hour, 300,000 kilometers a second, would take 9 years to get to Sirius. And if there was another Joe on a planet around Sirius and he decided to reflect that laser beam back at me, I wouldn't see that beam coming back for 18 years. 9 years there and 9 years back. As we head around towards further to the east, the Constellation of Orion, the mighty hunter of Greek mythology. Very easy constellation to pick if you've had a number of red wines. One of the problems with picking, especially the constellations that are supposed to represent a human, is that the constellations were created by the Greeks, the Romans, and the Arabs mostly. And of course, they were all from the Northern Hemisphere. So we see Orion in the Southern Hemisphere standing on his head. So you can see here, this little group of stars here makes up the head of Orion. There are the tips of his two shoulders. Beetlejuice and Bellatrix. There's the belt around the waist of Orion the Hunter, and here is two kneecaps, a Rigel over here and Saiph over here, and he's holding a shield up, and what hasn't risen yet in the eastern sky is his left arm, where he's holding a club, because he's actually at the moment fighting Taurus the bull, which is sitting over here. And this little V shape there, that's the face of the bull. And Aldebaran, nice big bright orange star, is one of his eyes. And here are his horns, one there and one over here. As we head a little bit further towards the northeast, I'm sure most of you have heard of the Seven Sisters. We refer to them as astronomers as the Pleiades.
So just quickly, Joe, we've got a question for you from Jamie Lee. Wants to know, is Betelgeuse bigger than our sun?
Yes, Betelgeuse is a much, much larger star. Betelgeuse, if we replaced our sun with Betelgeuse, you would find that most of the inner planets, that is Mercury, Venus, Earth, Mars, almost going out to Jupiter. It is a really, really large star.
Beautiful.
And
Thank you very much
as
for
we
the
go along here, as I said, there's the Pleiades. A beautiful view in a telescope. 7 bright stars that make up that little group. When you look at them with binoculars or a telescope, you'll be able to see many, many more stars. And the Seven Sisters are also the same symbol that Subaru cars use for the brand, and actually Subaru translates to Seven Sisters. As we head towards the north, obviously, if you're looking north and high up in the sky, you see a very bright reddish orange star. That's not always there, because that's the planet Mars. We've just encountered it on our path around the solar system, very close. We came within 57 million kilometers of it last month, and as we move around our orbit, we're actually leaving it behind now. But we'll talk about that in a little while and explain exactly what the mechanism that's going on there. But certainly get out there. If you have a friend or you know somebody with a telescope, get out there and have a good look at Mars. Always a nice view. The other very prominent constellation in the northern sky is Pegasus, the winged horse of Greek mythology. And the great square of Pegasus here is relatively easy to see, especially if you shade your eyes from street lights and that. That shouldn't be too hard to see. And at the bottom of here are the hind legs of Pegasus, and we'll talk about this area in much more detail later on. But we come to a galaxy called M31 by its catalogue number, or the Andromeda Galaxy, as we all know it. And we'll talk about that one in a little while. And I think that has been our walk around the sky. Many of the constellations that we have high over our head are quite faint. So if you live in the suburbs of Melbourne or the suburbs of Adelaide, there aren't many of these stars here that you can see, except for Achernar, which is quite bright, and that's the end of the constellation of Eridanus, the river, which stretches all the way from near Rigel in Orion. This is one of the longer constellations in the sky. All right, let's move on. One of the things I always like to talk about, because it spends half of its time in our sky each month, is the moon. And some of us who are what we call deep sky observers don't like to spend too much time outside when the moon's there, because it pushes out so much stray light into the night sky that it does blot out many of the fainter things, or the faint fuzzies, as we like to call them, that we like to look at. But the moon itself is really a fascinating object to study. You can do it with a very small telescope. You can see the craters and mountains on the moon really, really well. So if you were interested in looking at the moon, the best time to do that is later on in the month. At the moment, the moon's been very bright. It was new at the beginning of the week. Sorry, it was full at the beginning of the week, so it's been very bright in our sky during this week. By the weekend, it'll start rising about midnight, which means that it frees up the evening sky for you to start looking at darker, fainter things in the sky. So this area here is great for dark sky viewing right up until about the 20th of November, when the crescent after the new moon starts to appear in our evening sky again. So I always say dark sky this month, 8th to the 20th of November, and then if you're looking at the moon or double stars, 1st to the 7th or the 21st to the 30th of November. And whilst we're talking about the moon, I always introduce a feature on the moon that I like to talk about. And this month, it's one of the lunar seas. In this case, it's Mare Nectaris, or the Sea of Nectar. The red arrow here points to Mare Nectaris. The thin crescent moon, soon after new moon, starts to get bigger on this side. So usually around about day 5 or day 6 after new moon is the best time to look at this area. As I said, around 5 to 6 days after new moon. In our case, this month, it's around about November the 20th. Now, Mare Nectaris is an impact basin, which was formed a long time ago, very soon after the moon had formed, around about 3.9 to 3.8 billion years ago. Give you an idea, this size here is 350 kilometers in diameter. When the impact originally occurred, it was actually a bit larger. The impact crater came out to around here, and we'll talk about this area in a second. But the bottom, or the lowest part of the basin, was covered in lava and smooth, and the rest of it has remained quite pitted with later bombardment by meteors. This escarpment here, as I said, is basically the far edge of that impact, and it's known as the Altai Scarp, or the Rupus Altai. And this cliff face around here is around about 1,000 meters high. So it'd be quite a spectacular sight for astronauts that go to visit it. A few craters here. Fracastorius over here. This was a crater that had formed after the impact, but before the lava started to fill the bottom of the impact basin, and that lava flow actually melted the northern part of the crater and formed this horseshoe. This is 124 kilometers in diameter. Very, very easy for you to be able to see through a small telescope. Even with a small telescope, you should be able to get to view detail to within 2 or 3 kilometers in diameter. So the moon is a fascinating object to look at when you can't look at the faint fuzzies. There's a trio of craters at the edge of the basin here, Theophilus, Cyrillus, and Katharina. These, when the sun is just starting to rise over this area of the moon, can look really spectacular, especially when, as the sun's rays are coming from this end, they're illuminating this part of the crater rim and the little peak in the middle. So you see this little peak shining in the blackness. You see the crescent of the rim and nothing else. All this is still in darkness on this side. Looks quite specky. Certainly have a look at it. It's quite a deep crater. It's Theophilus is nearly 4,400 meters deep. So imagine the force of the impact that caused that. And lastly, I thought I'd highlight Piccolomini, crater Piccolomini over here. Again, it's got a little peak in the middle, and it's 88 kilometers in diameter. And you're probably wondering why some of these craters have got these peaks in them in the middle. Well, next time you're down in the park and there's a lake nearby, or you come against a pool of water, just drop a pebble in the pond. And when the pebble hits the water, you get that little peak rising. And that's exactly what happened here. During the impact, the whole area is molten, and the center rises up and it starts to solidify before it has a chance to go back down completely. Right, the planets, where are they? Well, we've already spoken about Mars. Mars is in the evening sky, shining very brightly, very easy to see. Venus and Mercury are seen in the morning sky at the moment. You can see them here in their orbit, and we'll talk about Earth and Mars in just a second. And these diagrams are for the middle of the month. And the outer solar system with Jupiter, Saturn, Uranus, Neptune, and Pluto over here. You can see here that if we're looking out from the inner part of the solar system, Jupiter, Saturn, and Pluto are all in a line. So that's why we see them in the same part of the sky. Just remember that they are separated by huge distances. That line of sight thing is just that. It's line of sight. It's not that they're all together, close together. Jupiter and Saturn are probably the easiest of the planets to observe with a telescope. Even a good pair of steadily held binoculars will show you Jupiter in much better fashion than the telescope that Galileo first made when he started peering at the heavens back in 1609. And he saw the planet and its 4 moons and deduced that those 4 little stars that he could see were orbiting around the planet. Jupiter is huge. If you could fill Jupiter with Earths, it would take nearly 1,300 Earths to make one Jupiter. The solar system is basically made up of our Sun, Jupiter, and then the rest of the planets which make up the rubble. It is a huge planet. It's got 4 major moons. They're called the Galilean Moons, named after Galileo, who first saw them. They are Io, which we can see in this image here, this diagram. There's Europa over here, and then Ganymede and Callisto as well. Now, those 4 moons, you can actually see them change their position in relation to Jupiter within half an hour or so. So that's something that you can do very easily in one evening. And of course, on the right, we've got the planet Saturn. I call it the glamour puss of the solar system. I don't think I've ever come across anybody who has looked at Saturn and not come away completely gobsmacked.
Just on that, Joe, the first planet, in fact, the first object I ever saw through a telescope was Saturn. And I tell people it's almost like someone stuck a photo on the end of the telescope. It was just so amazing to see the detail. It's stuck with me, and then I think it always will. Just the beauty of it through a telescope. It's hard to believe it's real.
Yeah, absolutely, Mark. Saturn was also the very first planet I ever saw through a telescope when I was still in early high school. And our science teacher took me to the Astronomical Society's observatory one evening. I took the whole class there, and we saw Saturn. I went home and said to my parents, "I want a telescope for Christmas." And that was really what fired up my interest in astronomy. I already had an interest, but looking at Saturn through a telescope absolutely blew me away. And that was the beginning 50 years ago now, over 50 years ago. And my interest in astronomy has never been greater than what it is at the moment. All right, so if we turn our eye to the west, towards the 19th of November, around about 9 p.m. or 9:30 p.m. for Victorians watching, you'll be able to see the moon, the crescent moon, Jupiter and Saturn very close together in the western sky. And if we give you a binocular view of it, this is what you would see: Jupiter, the crescent moon, and Saturn all in one view. That'll look quite spectacular. So put that in your diary, 19th of November. We mentioned Mars. Mars is in the northern, high in the northern sky at the moment, within the constellation of Pisces, the fish. Over here we have Cetus, the whale, Aries, the ram, and over here Pegasus, the winged horse. And we'll talk about him in a short while. But let's just concentrate on bright Mars up here. All you got to do is walk out the door and look high in the north, and you can't miss it. It draws you to it straight away. So, what's happening with Mars? Mars's orbit around the sun is not as circular as the Earth's is. So, because it's more elliptical than Earth's, there are times when the position of the two planets is such that they come quite close to each other, like 6th of October 2020, when they were within 62 million kilometers of each other. As Earth is closer to the sun than Mars is, it moves faster in its orbit. Mars takes twice as long to orbit the sun as the Earth does. So as the Earth moves around, it leaves Mars behind, as it's doing right now, so that you can see the gap here between the planets is getting bigger. So as Earth moves around, it leaves Mars behind, and the size of Mars in your telescope shrinks very, very rapidly. And over here we have some of the other dates over the next 15 years or so, where Mars is at opposition, so that both the Earth and Mars lie in the same line with the sun. So you've got the sun, you've got the Earth, and you've got Mars. So in 2025, the distance between Earth and Mars is 96 million kilometers, whereas last month it was only 62 million kilometers. So Mars will be much smaller. And it gets even worse in 2027. It's 114 million kilometers away. That's why we've been telling everybody that this opposition of Mars this year was the best you're going to get until 2035, for another 15 years. they start getting smaller again as time moves on. But enjoy it whilst we can, because it's just going to get smaller and smaller. Now, if you've got a large enough telescope and you've got good viewing conditions, you should be able to see some of the darker markings on the planet through your telescope. And if you'd like to be able to know what those features are that you're seeing on Mars, Sky and Telescope magazine has a website listed down here. Just put Sky and Telescope Mars profiler into your search engine and you find it straight away. And by giving it the your location, the date and time, you'll be able to get a diagram which shows you exactly which face of which part of Mars you're looking at that very moment. So, a really good, useful tool to have. Now, as I said, viewing conditions can vary, and this I think shows it really, really well. Two pictures of Mars taken very, very close together because they are showing the same face of Mars. This under exceptionally good, steady seeing, where the atmosphere above you on the telescope is really steady and stable, whereas this is taken under still what would be very good conditions, but nowhere near as good as this. Seeing detail on the planets, whether it be Mars, Jupiter, or Saturn, you want the best conditions that you can possibly get. All right, we now, for those of you that are insomniacs or rise very early, on the 13th of November, go outside first thing in the morning before the sun rises, and you'll be able to see a crescent moon and the planet Venus low in the eastern sky. Again, we'll bring in our binocular view, and there they are, Venus and the thin waning moon heading towards a new moon in a couple of days' time. I think new moon is on the 16th this month, so 3 days before new. But you'll need to get out there before the sun rises. All right, one of the other interesting things for you to look at this month, and this works really well because unlike the last few years, this happens at a time when there's no moon in the sky. So it's nice and dark, and that allows you to see many more of these meteors or shooting stars. The Leonid meteor shower, and we'll talk about why it's called the Leonid meteor shower in a minute. A meteor shower is when you happen to see a number of meteors or shooting stars as they flash from the sky that seem to come from the same point of view. We call that the radiant. That's where they're coming from. And what are meteors? Meteors, for most part, are made up of the debris that's been left behind by comets. Comets are dirty snowballs made up of gravel, small rocks, dust, all frozen together in ice. And as they come close to the sun's heat heats them up. The ice starts to sublimate and evaporate, and releasing some of that debris, and that gets left behind. There's a picture of a comet in the night sky. Actually, that was Comet Neowise, which was visible for the Northern Hemisphere observers at least really, really well just a couple of months back. And the material that we see from the Leonid meteor shower is associated with what's left behind by Comet Tempel-Tuttle. It orbits the sun every 33 years. And here's a diagram. This is the path of the comet through our solar system, and you can see the big debris trail that it leaves behind. And Earth just happens to run straight through that debris trail every year at this time of the year. The orbit of the comet takes it just past the orbit of Uranus. It takes 33 years to make that orbit, and as it comes in to our part of the solar system, as I said, the sun heats it up. It releases some of that debris, replenishes that debris field, and when the Earth goes through it, especially every 33 years, we get a really, really nice big shower. The last one we had was in 2001, and the seeing that meteor shower back in 2001 is probably one of the highlights that I could count on just the fingers on one hand of the most spectacular things I've ever seen in the night sky. One of them was when Jupiter got hit by a comet, and the Leonid meteor shower, which I saw in November 2001, will always remain in my mind as one of the most spectacular fireworks display I've ever seen. I was still seeing meteors streaming across the sky when the sun was just about coming up. It was one of the most amazing sights I'll never ever forget. This year, unfortunately, is not going to be as good. Back in 2001, I think I was probably seeing hundreds of meteors per minute. This year, probably 15 to 20 per hour. But it does make it easier because there's no moon in the morning sky this year. So, what's the best way of being able to see some meteors? They will all seem to come from low in the eastern sky, and I'll show you a star map in a minute to show you where it is. Low in the eastern sky, so make sure that you've got a nice clear view to the east. Make sure your skies are dark. So if you're sitting in a suburban area, go in the backyard somewhere where you're shaded from street lights and everything. If you can get away into the country to have a look, even better. You will need to get up early or not go to bed, because the best time to watch is around about 4 a.m. On the 18th of November. The night that we saw them back in 2001, the shower wasn't due to start till about 3-4 o'clock in the morning, but we started seeing meteors by just after 1 o'clock, and that fireworks display continued until after the sun had risen. And get yourself a nice lounge chair that you can sort of lie down on it and relax. Put a rug over yourself to keep warm and have a look. So where are you going to be looking? If you look low to the east-northeast, you'll see the constellation of Leo the Lion rising. Regulus is probably the best point of reference that you could use. It'll be the brightest star in that part of the sky, and the arrow is pointing to the area where the meteors seem to come from. Now, of course, they won't come just from that point. The debris field is quite large, but they will all seem to radiate from around about there somewhere. So have a good look at that. Keep warm, just lie down and a nice lazy boy and have a look. Hopefully it's a clear night for you. But I can't promise you that you'll see the fireworks display that I remember seeing. We saw this chart earlier. There was Mars and Pegasus, the winged horse, over here. Here's the great square of Pegasus. There is his long neck. There's his front legs. There's one of his hind legs down here. And if you can't picture that, let me help you. Well, I'll tell you about what that arrow is pointing at in a second. Here we go. There's the winged horse Pegasus. You can all see him now, can't you? That's easy. Down here is the constellation of Andromeda. Andromeda, the figure shares some of its shape with the hind legs of Pegasus, and also forms the figure of Andromeda, who was the wife of Perseus in Greek mythology. Over here we've got Taurus the bull that we spoke about earlier, and just outside of the picture we've got Orion the mighty hunter, just over here. Now let's go back to this arrow. As I said, this is called the Great Square of Pegasus, because it's nice, easy to find in the sky, and you need to find that one so you can sort of skywalk yourself from Alphatraz over here down to this star, down to Merak, and then follow these stars here to, if you're in a dark sky, you'd see a little fuzzy spot just about there. From the city, you won't see it with the naked eye. You'll need to trace this area with binoculars. So start over here with Alphatraz and move your way down here until you come to this spot, and you'll find a little fuzzy spot in that area. And that fuzzy spot is labelled M31, which I mentioned to you before was the Andromeda Galaxy. Andromeda Galaxy is 2.5 million light years away. Let's just bring it up. Now, you'll never see the moon near the Andromeda Galaxy. The moon doesn't follow a path anywhere near there, but the chap that produced this image actually superimposed the moon actual size compared to the Andromeda Galaxy in our sky. So you can see that the Andromeda Galaxy is around about 6 times the size of the moon in our sky. So you'll definitely need a pair of binoculars in order to be able to see the full length of the galaxy. A telescope will only show you a very tiny portion of it. As I started to say, 2.5 million light years away. So that little laser of mine would have to be very, very busy and very tired by the time they got to the Andromeda Galaxy in 2.5 million years. It's similar in size to our own Milky Way galaxy, and our own Milky Way galaxy, should we be able to travel outside of it and far enough, would probably look something like this, a beautiful spiral galaxy. Easily seen with the naked eye if you're in the country in a dark sky. The Andromeda Galaxy is always one of the targets for everybody who goes to the VicSouth Star Party at Little Desert Nature Lodge. As I said, its apparent size in the sky is about 6 times that of the full moon. And one of the things that I need to tell you, although I don't want you to lose any sleep over it, but both the Milky Way galaxy and the Andromeda Galaxy are traveling towards each other, and they will collide in about 3 billion years or so. So don't lose any sleep just yet. We don't have time to talk about exactly what will happen when they do collide, but even if I was there, I wouldn't worry. We might as well stay in the same part of the sky, and the red arrow here is now pointing to something called M33. This is another galaxy. Again, something that looks fairly similar to our own galaxy. Again, a good target for your binoculars. And here she comes. Unlike Andromeda, which is quite tilted to us, this one has only got a slight tilt, so we almost see it face on. You can see the center of the galaxy here, and here are the spiral arms, almost like a spinning Catherine wheel. Absolutely gorgeous. However, those two aren't the only 2 galaxies that we can see with the naked eye in our nighttime sky. If you, instead of looking north, if you turn around and look to the south, high in the south, and just assuming you're in a dark sky and you've got clear skies, you'll see two little patches, bright patches in the sky that look like clouds. They're actually external galaxies. They're satellite galaxies of our own Milky Way galaxy, and they're called the Magellanic Clouds. They're named after Ferdinand Magellan, the Portuguese explorer who first saw them when he was traveling the South Pacific back in the late 1400s, early 1500s. Let's have a look at each one in turn. Actually, I think I've got a photo that shows both of them. Here we go. Here's the large cloud, and here's the smaller cloud. And this object here we'll talk about as well, unrelated, these two, just in the same line of sight. This is the large cloud, and this is the small cloud. So let's go back to the large cloud over here. And there's a close-up image of it. It's, as I said, it's a satellite galaxy of our own Milky Way galaxy. Unlike Andromeda, which is 2.5 million light years away, this one is only 158,000 light years away, so much, much closer. It's got a diameter of about 14,000 light years. There's about 1 billion stars estimated to form this galaxy. And to give you an idea of the apparent size in the sky, it's about 20 times a full moon. So it's a very large object. You won't even fit that in your binocular field of view. And just like the Andromeda Galaxy, the Large Magellanic Cloud will also collide with our Milky Way galaxy before Andromeda gets here in about 2.4 billion years. Both the large and the small cloud are being eaten up by the Milky Way galaxy, and astronomers have noticed that there is bridges of gas and stray stars already joining the large and small Magellanic Clouds to our own Milky Way galaxy. Our Milky Way galaxy has been a cannibal. Let's go to the small one now. This one is slightly smaller, only about, in the sky, about 10 times the size of the full moon. So you still only just barely get it within the field of view of your binoculars. Binoculars normally have a field of view of about 7 degrees. The apparent size in the sky of the small cloud on the long edge or long end is about 5.5 degrees. So you just fill that into your binocular field of view. This one is slightly further away at 199,000 light years. It's about half the size of the large cloud, and is estimated to contain around about 200 million stars. The other object in this field is this one here. As I said, it's not related to the small cloud at all. They just happen to lie in the same line of sight. That one there is 47 Tucani, or by its catalogue number, NGC 104. It's a globular cluster. A globular cluster is a...
Sorry, I was just going to say, did you explain to them what the NGC stands for? Did you explain to them what NGC stands for?
No, but I was going to.
I'll leave it with you.
Yes. Remember before, and I thought about explaining the M numbers earlier with M31 for the Andromeda Galaxy and M33 for the other galaxy in Triangulum. They are catalogues that astronomers use, and the M numbers were items that were catalogued by a French astronomer back in the late 1700s called Charles Messier, who was actually making up a catalogue of objects that he could exclude as being comets, because he was a comet hunter. So he made up this catalogue of 110 odd objects that if you came across it, you knew that it wasn't a comet. So you could just leave it alone and not worry about it and keep on your search for comets. Now, there is another catalogue which is created much, much later and has many, many more objects in it, called the New General Catalogue. And this object here has an NGC number of 104. So it's 104th object within the NGC catalogue. And this object is not a galaxy, is actually a globular cluster. It's not a cloud of gas. It's a big ball of stars. Contains probably between 1 and 2 million stars, all arranged in a ball. And there's a group of these globular clusters that form a halo around the center of our galaxy. I think there's around about 120, 130 of these objects. This one is the second brightest one in the sky. Omega Centauri in Centaurus is the brightest one. So here in the southern hemisphere, we have the two brightest objects, two brightest globular clusters in the whole sky for us to look at. And if we get lucky tonight, one of our people with waiting outside patiently with a telescope might be able to show us Omega Centauri, 47 Tuc through the telescope. Easily seen with the naked eye, as long as you've got a relatively dark area to look from. Even that alone is nearly twice the size of the full moon. So it's quite a spectacular object to look at. Anyway, I've just looked at the time. Gosh, I can talk.
I know. I've just noticed it's 9:30.
I've used up more time than I was allowed. So I think I will finish there. Right. One of the things I should tell everybody though is these star charts that you see in the background that I've been using all evening were created with a software package called Stellarium. It's free. Just put Stellarium into your search engine. You'll find it. You'll be able to download a version of it, whether you're using Linux, whether you're using a Mac, a Windows machine. Download it, install it on your computer, and you can generate charts like this at your heart's content. So I'll finish that now. If there are any more questions, Mark, certainly put them through to me, and I'll just.
We will, as we look at the objects, people will ask questions, and we will pop them up, and we'll get everybody to answer as best they can. So I'm going to bring Perry into the chat. Good evening, Perry. How you going?
Hello, Mark. Hello, Joe. Good to see you again.
Perry. Did you see, mate? I did it especially for you. I put M31 in the list of objects.
Beautiful.
I thought Perry will never forgive me if I don't include the Andromeda Galaxy in there.
Yeah, it's a little bit easier to see for you guys, though, in South Australia, because you're a little bit further north. For
exactly.
Us, down here in Melbourne, it's a little bit lower in the sky, so it makes it even more difficult. So I envy you and your skies in Adelaide.
Now, I believe that we've got people out there with telescopes all waiting to show us.
We've got Noel. We'll bring everybody in for the moment. I think that's everybody. Andy's hiding in the background somewhere. He's not quite there. Perry, I'm just going to pop you back off and bring you back in because your audio was a little bit out with your video. So I'm going to see if that helps. We'll try and do that. There we go. So we've got Noel from the ASV. We've got Kim, who's from the Astronomical Society of South Australia, and Paul as well, who's from the ASSA. Paul's going to give us a talk tomorrow on planetary processing, and Perry from the ASV as well. So Kim and Paul, I know you guys have clear sky at the moment. Noel, do you have clear sky at the moment?
Yeah,
partially.
It's okay at the moment. Yeah.
I might bring Paul. I might bring your all sky camera in for everyone to have a look. So that's your view right now out there. You've got a little bit of cloud, but you've got some clear sky by the looks of it.
Actually, Actually, can you just see that line there in the middle of the screen there?
Is that the ISS?
That's Starlink going across.
Okay, yeah.
The infernal Starlink.
The evil Starlink. So, guys, we have a question.
So you can see that going over in the track. So,
yeah. We have a question from...
I've got a question.
Okay, well, Perry, you first, then I've got a question from one of our viewers.
Thank you, Mark. Paul, could you please explain to everyone what Starlink actually is and why it's not?
Okay, all right, there's another group coming over now. Okay, so Starlink is Elon Musk's version of broadband information technology and uplink, so that everyone across the planet apparently can have broadband. They're a group of satellites. You can see there's a group moving across now. Yeah. They typically look like a small train, like 7 or 8, 9, 10 dots travelling along together. The reason why you can see them as a line now is simply because this is a 20-second exposure. But over the course of the last 18 months or so, there's been a significant number of them launched into space. There'll be around 40-something thousand of them eventually, with the idea being that they'll be in a higher orbit, so they won't be as easily visible. However, they are a bit of a problem for astronomers and for people like myself who do deep space astrophotography. So right now we're just seeing them go passing across. They're typically visible at this time of night when the sun is below the horizon, but not that far below the horizon. And as a result, you can see them moving through the field of view. So I think that pretty much covers what Starlink are, other than them being called infernal.
All right, so we have a question from one of the ASV's Brazilian members. Sergio joined during our September Star Party, and he wants to know if there's anything interesting for 2021 to observe when we come into the new year.
Well, can I have a go first before anybody else does? Hello, Sergio. Good to hear that we've got ASV members in Brazil. I'm going to give you something interesting to look forward to before the new year. In fact, just before Christmas, a couple of days or so before Christmas this year, if you look at the western sky, you will see that Jupiter and Saturn will be incredibly close together. In fact, they will be so close together, if your eyes are as bad as mine, they could possibly look like a single object.
It's going to be pretty impressive, that one. Thankfully, we're out of lockdown, so we'll be able to actually see that.
Just don't forget that it will be quite low in the sky, only about 13 degrees above the horizon. But if you can manage to see them, both in the same field of view of an eyepiece, you'll be able to see the Jupiter and its moons and the Saturn and its moons and the rings all in the same field of view of your eyepiece.
I'm going to try. I'm sure there'll be a lot of astrophotographers or planetary imagers. Paul, you in particular, I'm sure you'll try and image that.
I'm a bit intermittent with my planetary imaging now. I've got to juggle time between taking mega hours on deep sky objects and keeping my wife happy. So, spousal happiness is a big part of the problem in this astronomy caper. So, I'm just going to pop on an image. I'll share an image of IC 5148 that I've just taken in hydrogen alpha. So I'm just sharing that up now. So can you see that there? That's about 180 seconds on this. It's a reasonably smallish planetary nebula. Sort of interesting object. It actually has in much deeper images, a very broad halo that surrounds it in O3. So if you've got an O3 filter, you can sometimes catch a small glimpse of it. But this is mainly what you'll see when you look at it. So that's 5148, IC 5148, Planetary Nebula, looking exactly, almost face on. The core star's here. There's a bit of a slight torus around the outside. So,
Can you explain for dumb people like me, Paul, what an O3 filter is and what it does?
Okay, so there's three main types of imaging filters. Actually two main types. Broadband, which is luminance and red, green and blue filters. And then there are narrowband filters, and there's a spectrum of three main types of narrowband filters that most people use. Hydrogen alpha, which covers about 656 nanometers. So very narrow field of light passes through in hydrogen alpha, and that mainly captures hydrogen light and all that sort of thing, and photons. Then there's O3, which is oxygen 3, again, mainly in the blue spectrum, but and very narrow bandwidth. But O3 is very faint and very hard to detect, and so it requires quite narrowband. So most of these filters that I have are around somewhere between 6 and 5 nanometers. A few of them are around 3 nanometers. And S2, of course, is the last of the narrowband filters that are commonly used, and that's for sulfur 2. And the 2 and the 3 and the alpha is obviously, that's pretty obvious. Hydrogen, oxygen 3 is just oxygen, the actual third ionized oxygen, and sulfur 2 as well. Does that help, Perry?
It does, and it's probably worth pointing out that these filters also work well for visual astronomy, and you can also get what we call light pollution filters. I use one made by the Orion company called Orion Ultra Block. So if you're in the city and you've got a lot of lights around you, some of these light pollution filters can help you to get better views of nebulae, not galaxies or planets, but gas clouds, nebulous gas clouds. You can get a better view of them even with strong lighting nearby.
I'd like to point out, though, that imaging filters are slightly different to visual filters. It's highly unlikely you'd actually see through, using an imaging filter to see through those filters with your eyes, whereas something like a high contrast filter used for, say, looking at Planetary Nebula, for instance, it's easier for the eye to see through it. So there are slight differences, but yeah, essentially that's correct. Yeah.
So we've got so this is your spare tire nebula, isn't it?
Yes, that's the spare tire nebula. I
was joking earlier, guys, off on the private chat that we've got, obviously, with the program, that I asked Paul if it was a full-size spare tire, if it was one of those space savers. We haven't quite worked that out. It kind of looks a bit like a space saver to me.
Well, in my car, there's no spare of any size whatsoever. There's a little can of stuff that pumps up your tire, and that's it.
That's it.
Someone made a comment there about. Someone made a comment there about. Thought it was the Eye of God. No, that's a different one. That's the Helix Nebula, which I'm gonna try and get something for you in a little bit. But that's a much bigger nebula. That's roughly speaking around the size of the Moon, give or take. So, as in apparent size. So this is much smaller again. That's very tiny.
So
maybe
Lee again is asking
we
about,
also, Paul, Mark, or maybe Joe. Maybe Joe can explain what planetary nebulae actually are. Joe, can you tell us about those?
oh, you're muted, Joe. You've got yourself muted.
You're muted.
You're muted, Joe.
Yeah.
There we go.
I was going to say, whilst I talk about the planetary nebulae for a second, perhaps we can start bringing him in because he has been imaging 47 Picardie, that NGC 104 globular cluster that I was telling you about earlier.
Yeah, he did. He did.
Let's just talk about planetary nebulae. It's a completely misnomer. It's got nothing to do with planets whatsoever. It's just that many, many years ago, before astronomers knew what they really were, it just reminded them of a planet. But it's actually the shell of gas that's been expelled by a star in the throes of using up most of its nuclear fuel. The star sort of has a hiccup, and this gas and material spreads out from the star. And if we happen to see it face on, then we'll see it as a nice big spare tyre for you, Perry. Or it may have a slightly different shape depending on our angle of view. But a planetary nebula has got nothing to do with planets. It just resembles that a small planet in a telescope.
Another thing about planetary nebulae is that many of them have a sort of powder blue colour to them, and it can be quite striking when you see it through a telescope. They can be some of the few objects that actually display a strong, well, even though it's pale, it's still a visible colour that you can see in a reasonable sized telescope, and worth noting it when you do have a look.
A good example is the blue planetary just near the Southern Cross.
Yes,
that
indeed.
shows up really deep blue. All right, let's hand over to Kim, because I think that's his telescope there.
Thanks,
what are you going to show?
I'll just talk to this. I'll just talk to a couple of slides first, just describing the equipment I've got, and then I'm going to show some images which I've been taking real time from not my backyard, but my front yard.
Yeah, are you also going to tell us about your roses there, Kim? They're very impressive.
Another day, Perry, another day. I refer to them as the presidential rose garden these days. Okay, so this is a relatively small telescope, and I'll describe, but it's actually highly advanced, and I'll just quickly describe its features. That's a photo of the whole thing. Next slide, please. I'm not in presentation mode, of course. All right, so this is a close-up of the whole beast. And this is an 80, and I'll just go to this next slide. Okay, so this is an 80mm refractor. It's a fluorite doublet made by William Optics. Now, I bought this telescope over 10 years ago as a visual telescope. And over the last year or so, I decided, well, I'll convert it to an imaging scope. The technology has advanced so much for imaging the night sky in recent years, and even during this year, that I thought I'd buy a few cameras, advanced cameras and some advanced computers, and see what I could do with it. Very small scope in a light polluted part of Adelaide. It's Bortle 8 where I am. I'm not even 5 kilometres from the city centre. And I have a wonderful LED street light hanging over this, which is probably no more than 15 metres away. Anyhow, from there you can still image, which is pretty amazing. So this is what I've got. Okay, here's the aperture. It's a refractor. There's just a couple of big lenses in there. And this is the camera down the back end here. And it's a special camera for taking astronomical images. It's also cooled. So the camera is currently operating at 0 degrees C, but can go a bit cooler. I've just let it go to 0 tonight. There's a little camera on the back of this little telescope up here. That's called a guide scope, and that helps keep the images together with the camera so the stars are pinpoint during the exposure. So any errors in tracking the night sky are automatically notified to the main camera by the little camera, but the little camera notifies the mount, which is below here, which then makes adjustments ever so slightly. And I'll show you what that looks like in a minute. There's an electronic focuser on the other side of this, so the telescope automatically focuses at certain times during the night. And there's a mount at the bottom here, which keeps it pointing in the right direction. What else is there? Oh, this little box at the end here is just magic. I mean, this is essentially an astronomical computer. It's actually a Raspberry Pi. This version has a power supply on it as well. Sorry, a number of 12-volt power outlets, which feed the electronic focuser, and also, what else is this feeding at the moment? It's feeding the hub, and anyhow, this is a very versatile system, and I thought I'd see what I can get with this, and I'll show you some images that I'm taking through this, and I'll do it in real time tonight. This is another shot of the scope, and here you can see the electronic focuser on one side. Now, this particular mount is very versatile. I actually use it to mount not only one telescope, but 2 telescopes. That's the one on the left is the one I just showed, small refractor, and this is a 9¼ inch Schmidt-Cassegrain system. And the idea behind this configuration at the time when I bought it in February this year, meaning the mount, was so I can connect a camera to one of these and use the other one for visual at public outreach events. That was just before COVID started getting serious, and that hasn't actually been realised yet, but the capability is there. This is a very versatile system. You can use it with just the larger scope, and I've used that recently just for some planetary work. And this is it again in the front yard, just imaging. These are pretty well my first, or actually second, images I took of Mars and Saturn a few weeks ago through this setup. Planetary imaging is very, very challenging. I'm happy with my initial results. I don't really know how to process the images properly. I also like to do things on a Mac computer, and software's a bit. The software is a lot more abundant on PC, so I'm still finding my way on a Mac. Anyhow, that's what I wanted to show you there. I'll now show you that the computer. I mean, the telescope is out the front, and the computer is attached to it. I'm sitting inside, as you probably gathered. So let me just hook up my iPad. So this is a screen of my iPad right now. You can see that. I'm sharing it.
Do that for you. There you go.
Thanks, Mark. And that's an image I took of 47 Tucanae, the globular cluster that Joe talked about earlier. And I've stopped imaging. I started imaging around the time Joe started talking. I thought I'd better stop, otherwise I'd burn out the frame. But it ended up being a stack of 33 images, which you can see the numbers down here. And I think they were 10-second exposures each. So the image literally forms in front of your eyes when you do this. I'm connected wirelessly at the moment to the computer on the telescope. I'll just get rid of the guide for a moment. And I'm just touching the iPad screen here. In fact, I can get rid of all that. And you can see, I can just zoom in, and there's a lovely image of 47 Tucanae. That was literally taken from while I was sitting inside. The telescope's outside. All right, so now I'm going to take another image, and I'm going to show you the process for taking an image of the Tarantula Nebula. Now that's a very large nebula in an adjoining galaxy, the Large Magellanic Cloud. This cluster here, this globular star cluster, is about 13,000 light years from us. The Large Magellanic Cloud is about 180,000 light years, but it's got this massive nebula associated with it. So I'm going to just show you the process for how one finds these objects and images them. I'll exit that. I'll just type in here, I need NGC 2070, which is the object. I'll just type it in here, NGC 2070. I might even have it here. No, I don't see it there. Okay, so I'll just type it in. 2070, search, and there it is. I'll just tap on it, choose. All right, so now the telescope is going to slew to that object. Now, one thing it does we don't do star alignment with this package. We actually use a technique called plate solving. And what that means is the telescope the computer will instruct the telescope to take a series of images very quickly and determine where it's actually pointing versus where it should be pointing, and then make adjustments to the mount so the target is actually more or less in the center of the field of view. So I'll tell this to go now. So it's started to move. So the telescope is slewing at the moment, and I can show you that with another security camera that's out the front. But it does, for some reason, it affects the volume on my computer here. So I won't activate the camera just yet. All right, so it's slewing to the target position, which shouldn't be very far. And when it gets there, it'll take an image. I'm just going to have a quick look on my phone to make sure it is actually getting there. Okay, so it's there, and it's centered the target. And I'll just take a quick preview shot. That is not a good shot. I'll just clear that. All right, I'll just take a 10-second exposure on it, unless I'm looking at a street light. Hopefully we'll see something. Auto, that's all. And there it is. All right, so what I will do now is I'll start taking a series of images. I'll just adjust the position slightly. It's a bit off center. And this is a bit of a guessing game for anyone who's done this before. I'm just going to tap that one. I might go back to it.
Is it possible for you to point it out with a cursor? Is it possible for you to point it out with a cursor, just so people know exactly what you're referring to?
Sorry, I was using my fingers on the iPad screen. Can you see my cursor there, Perry?
No.
No. Okay, well, I can't do anything about that, I'm afraid.
Okay, fair enough. If you center it, it'll be the same thing.
I'll try to center it. Okay, I need to take another photo. Hold on. I'll just get it more or less centered, then I'll just start exposing. Wrong way. All right. Take one more shot here. All right, that's good enough for now. Okay, so center's there. It's a bit off center, just above. So, so that's basically one image. That's a 5-second exposure. I'm going to now set this so we take a series of images, and I'll just let it run. So I'll go auto run. No, I don't want to do flats. Go back. Actually, I'll do live. Can't delete that. Go back. I'll do live stacking. So I've got live stacking. And what this will do is just take a series of images and keep putting them one on top of the other. I'll just keep them at 10-second exposures. And I'll just start now. And this will just keep taking images every 10-second exposures, and then put them on top of each other like essentially a pancake, and the image will gradually get better and better with time as more and more images are data is accumulated. And so I'm just going to let this run for, I don't know, 20 or 30 exposures. And we can come back to it later if you like. You see some of the colour starting to come out now after 2 exposures. I'll just get rid of the back. Yeah.
This is much more fun than watching grass grow.
Yeah. Okay, that's good.
Yeah, I'm actually watching the nebula get brighter and more colourful with every exposure. It's looking good.
I'm not. I just realised I'm not guiding on it at the moment, but I don't think I need to. It's pretty close. But maybe I should turn guiding on. Let's have a look here. I know that's okay. That's going. Guide.
Now, whilst we're watching that nebula, that big gas cloud get bigger and bigger in the picture, we're fortunate that is 180,000 light years away. Because if it was within our own Milky Way in our part of the galaxy, that object would occupy a third of the night sky and be visible in daytime. That is a huge cloud of gas and dust. New stars are forming inside there all the time.
Oops, I'm just going back to the wrong part.
Okay, we've got a question here for you. What's the focal length and effective f-stop of your telescope?
So there is a focal reducer on that telescope. It's normally f6.9 at 555 millimeters, but with a reducer, it brings it down to 444 millimeters. So I think it's around f5 point, what I say, 8, was it 7? No, it's around f5.6 or something. So it's not that fast, but it's as a refractor, it's a very and as a fluorite doubler. Actually, the images, the star images, are quite nice.
There we go, wonderful. So we have Jen from the ASV up in Swan Hill. She is currently the only ASV member with clear sky. She's got her camera hooked up. So while yours is stacking, Kim, I might chuck Jen's on.
Yep, do that.
We can have a look at what she's been. I'll bring Jen in as well.
Yep.
Jen, how you going?
Hi guys, how are you?
We were talking about this one earlier, weren't you, Kim? The wonderful Helix Nebula.
I'm currently taking 5 minutes in HA.
There we go. So what's your equipment, Jen?
A Skywatcher ED120 with a ASI 1600 mono camera.
Now, Joe, did you want to tell us a little bit about Helix?
It's another one of those planetary nebulae that we were talking about earlier. As Paul said, this one, the Helix, is much, much bigger than IC 5148 that he showed us earlier. The apparent size of this in the sky is bigger than the full moon. So it's an object whose shell of gas has been expanding for a long, long time.
This is the 18-inch mag wheel version. This is not the space-saving spare tire.
Yes, exactly right. Exactly right. That is because it's so large. Its light is spread over a large area. Therefore, it's a lot more difficult to see than some of the smaller planetary nebulae, where the light's concentrated into a small area and therefore brighter. So you really do need a dark sky and good contrast in your telescope for you to be able to see this visually. When people like Jen or Paul are imaging it, the end result is absolutely spectacular. But don't ever expect that you'll see the same thing when you're looking at it through a telescope with your eye.
Yeah,
it will just be a very faint wisps of cloud in the eyepiece. But when you know what it is, it's still spectacular.
it is. So Andy, who's hiding, you go, Perry, and then I've got.
Oh, thanks, Mark. The other thing I was going to point out, and unfortunately I can't enlarge Jen's image of it, but usually in the center of these objects, you can find the Progenitor Star. In other words, the star that gave birth. There we go. Can you point to it, please, Jen? Or is it Mark, whoever's got in the middle?
No, it's Jen with the mouse. It's the one in the middle, isn't it?
Right in the middle.
It is the one in the middle.
That's
Yes.
it. So what's left of the star about the size of our sun is now just a small example of itself, because it's pushed the outer layers of its atmosphere out into space when it's reached, as Joe said earlier, when it reaches the final stages of its life. So this is basically a look into the future of our sun, because that's what will happen to our sun. It's not going to go supernova, as some people may have thought, because it doesn't have enough material, enough mass to do that. It needs to be about 10 times the mass of the sun for a star to go supernova. So anything about the size of our sun does this sort of thing at the end of its life, just pushes out the outer layers of its atmosphere into space, and what's left is the hot core of the sun.
So we've got, I muted Jen for a second because she was getting some reverb and her sound was up a bit too high. That's a bit better. So we've got a question, Perry, which kind of leads on to what you're talking about there. David wants to know, do you ever get to see the white dwarf core of a planetary nebula, or are they too small?
This sort of is a white dwarf, but there are some examples that you can see in the sky, but you need to have a sizable instrument with enough, if you're looking at it visually, that is, not photographically. All bets are off when you use cameras, because cameras can take long exposures, whereas the eye has to immediately see whatever it can in the eyepiece. Although there are techniques that you can use visually to improve what you're actually seeing in the eyepiece, but they might be something for a different time to have a talk about that. But there are some white dwarfs that are visible in telescopes with your eye. Another one is the pup, which is the companion to the dog star Sirius. Currently, or over the last few decades, those two stars have been very close together, but for about the last 5 to 10 years, they've been separating, and they're a little bit easier to see in a telescope, but you still need to have a night of very good steady seeing and enough firepower in your telescope, plus some visual observing techniques that you can use in order to be able to see it. So that's a complicated answer where, in fact, I could have just said yes.
That's all right. So Paul's just let us know he's got a high-res version, or what'd you say? Oh, hang on, we'll bring Paul in. We'll put that.
It's a high-res version of the Helix. So I just this is slightly longer focal length of what Jen's working with. I'm using a 12-inch Orion Optics telescope, Newtonian telescope with a 683. It's a monochrome image of in luminance, but of interest, I think, with the image is you can see the cometary globular nodules that are contained within the nebula, and they're like little spots radiating outwards. And you can see that further around on the outside, when the brighter section, you can see that there's these radiations of the nebula. Now, as you image that further and further with and this is a hydrogen alpha, sorry, not luminance. In hydrogen alpha, you'll get there's actually 6 distinct shells that can be seen of this nebula further and further out. So this is only just 270 minutes so far, but I did an image project on this object a couple of years back where I did 111 hours, and you could see right out to the outer chevrons here. Yeah, only that all, yeah. Yeah, so It's a sort of one of the pet objects of mine, I guess. So, but I thought, yeah, Jen's object is very good for the size of a refractor, and shows you what you can get with a refractor. But of course, you can always go bigger and bigger with a bit more image scale. So, one of my favourite objects in the sky, that's for sure.
Getting back to those cometary globules that you were talking about earlier, Paul, they always kind of remind me of a bicycle wheel with the spokes coming away from the central hub.
Indeed, yeah. It's sort of interesting how that object looks.
It is. It's a beautiful object to look at. This is a colour version that Andy has been working on over the last few nights. He's got cloud at the moment, so this is one of his previous images. What are you using to get your images, Andy?
G'day, everyone. It's just a Skywatcher 150 mil Newtonian with an old Canon EOS 450D. It's been modified. I'm just going through Canon EOS at the moment. Just a big tick. I'm back to here. Find it. Yeah, I'm just sort of going through some of my images now, and I've just noticed a satellite going through this one. That was a couple of nights ago. So these are my images I'm sort of stacking at the moment. Yeah, that's just simple equipment. Just a 6-inch Newtonian guided and with a Canon 450D.
How long are your exposures for these?
These are 5 minutes, 300 seconds. And I don't know if you can see the details here. Yeah, 300 seconds, 10 degrees. Yep.
Oh, there it is in the corner, yeah.
Andy, could I ask a question?
Yep.
You said very simple equipment. Can you please tell everyone how much your very simple equipment costs?
Probably about under 1,000. Right. What I'll do, I'll show you a picture of my simple
For what?
second hand.
For what?
For what?
Yeah.
For my scope, mount, and camera. Yeah, so I got the scope $200, a $200 scope. Here it is here. I don't know if you can see that, guys. Yeah, it cost me $200 second, everything second hand. My camera cost me $220, and my mount was $700. So yeah, probably $1,100.
And what about that beautiful portable shower in the background?
Yeah. that's my imaging scheme.
That's where he sits when we do streaming, Perry. That's exactly where he's sitting when he does his live streams with us, with his image. That's it.
And I've got a beaker in there. But at the moment, I'm in my room because it's just not even worth sitting out there at the moment.
So Andy wants to know, what software package were you using there?
Backyard EOS. It's just a program. I think it's about it's pretty cheap, $50, I think. Might even be less, but you can use the free version. But this is a Backyard EOS, and then I mainly use after that I'll run it through Astropixel processor to stack it. I've tried Deep Sky Stacker, but pretty well just my capturing software is Backyard EOS. And yeah, I've just bought second-hand gear and just use cheap software, and but astropixel fluorescence, I think that's another $20 a year, maybe a bit more. I'm not too sure because it's more of a yearly rental. And then Photoshop, which costs a bit more, of course.
You've done very well, Andy, because I know people that have spent as much as $20,000 on astrophotographic systems.
And the rest.
Yeah. And the rest. Who said that?
A lot more. Me. A lot more.
Well,
Lots.
Hang on. And are you still married?
Yeah. My wife is very accommodating of my obsession.
So what sort of deal with the devil have you struck to be able to convince your wife to do that?
I can't really tell you that.
Just
quickly.
Did you sacrifice an astrologer maybe or something?
No one's going to miss an astrologer. Andy, so Lee wants to know, is the 450D altered with the IR filter removed?
Yes.
It is.
Yes, it's been removed, yes.
You've butchered it.
But I've also bought a few, okay, I'm sort of looking here. Yeah, I forgot about my guide camera. Yeah, that was $200. It starts adding up, and then you're cabling and then all that, you know.
It's not as cheap as you initially said.
No, and then you, but still, it's because I bought everything secondhand. New, yeah, it would have been in about $2,000 worth, roughly. But I think what my main luck is having bought a One Skies. I think that's my that helps a lot. You know, I'm not filtering anything. The only time I put my I bought a hydrogen alpha filter, and I put that on only when the moon's up pretty well. Just for, and I've done a little bit of it, HA, but pretty well.
So then the other question
gear.
The other question is, where do you find your second-hand gear?
I found mine mostly on Ice and Space. It's a pretty well in the second-hand gear. It was a while ago, and I just kept on watching until I found something at the right price and just went for it straight away. I mean,
Gavin's the least patient person I know. He won't sit and watch anything. He'll end up just buying it new.
Yeah.
So, Kim, your Tarantula Nebula stack is looking quite impressive.
And actually, maybe this might be an opportune moment to talk about why it's called the Tarantula. Joe, do you want to have a go at that?
You raised the subject, you do it.
I always thought it was because it looked like a dead spider on its back with its legs curled up.
Yes, it's those spindly legs and loops are all representing the daddy long leg sort of shape of some spiders, really.
It's a beautiful object to look at. And I know when we put the O3 filter on, it looks even better. Pops.
Yes, I agree.
Visually speaking, when you look at that with the O3 on, it almost looks 3D through a good scope. Yeah.
I can. Joe talked about when he first saw Saturn. I can remember the first time I saw the tarantula. I had an 8-inch telescope, and looking at it from a dark sky sight, I had never seen it before, but as soon as I saw it, I knew immediately what it was, and I was just knocked out.
Yeah, it's pretty impressive. I think the first time I saw it was through the 25-inch at the dark sky site. So I was a bit spoiled.
Hell yeah.
Yeah. Yeah. So it was quite a sight to see through that telescope, that's for sure.
The other thing to note if you ever have the opportunity, if you're a member of the public, to have a look at the tarantula, you will see all around it lots of other little bits of nebulosity, because the Magellanic Cloud has, well, first of all, as Joe said earlier, it's about 160,000 light years away, but there's other little bits of nebulae all the way around the cloud. So if you move the scope slightly to the left or to the right, you pick up lots of other little bits of gas that are part of this galaxy.
So just quickly, Kim's having some trouble with his audio, but he's let us know he's going to, we're going to do a live slew to, what do you say, to Pluto. Let's see if Perry can pick it.
Yeah, it'll be a cinch, no problem.
Yeah, here we go, Kim. We've got that back up. So here we go. Kim's camera is going to slew. So this is so yeah, he's pointing to where it is between Jupiter and Saturn there, those two stars in the top left corner of the screen. And we're going to, there it goes. Look at it move.
It's alive! It's alive!
I think I need to get Blake one of these little cameras. He needs one so he can sit inside and watch his camera slew when it moves around. That's quite a magic thing to watch. I know it's just a simple thing, but to see it actually move to the object. Now, Kim, you have to take some images of Pluto and point it out to us. You know that. Everyone's going to want that. The level of expectation has been raised.
Might I temper everyone's expectations a little bit?
You better.
It'll look just like a very faint star, no different to all the other faint stars in there. I think if Kim's audio was working, he would tell us that the way to confirm the object is to take a photograph tonight, and then tomorrow night, or perhaps the night after, take another photograph of the same part of the sky and watch or look to see which one of those stars has moved slightly. And that will be Pluto. And in fact, that was how Pluto was discovered back in 1930.
All right, Perry, I got my sound back. For some reason, when my security camera is on, my audio gets whacked. So can you hear me okay?
Yes.
Great. Okay, so that's exactly what I'll do. I'll take a series of images tonight and stack them. And then tomorrow night, I'll take another series of images, and you'll be able to see the pixel that is Pluto. I was going to say planet. Let's call it a pixel. Jump.
Yeah.
So we're going to do, this will be a continuation tomorrow night. So everyone who's watching now, if you come back tomorrow night, we'll be able to show you the difference between tonight's images and tomorrow night's images, and then work out which one of those stars has moved, and therefore we can work out which one is Pluto. That's a bit of light in the bottom corner of your photo there, isn't it?
Yeah, I don't know where that's coming from. I think I know I saw a car drive off, just not on the videos.
No, that's a flare. That's a bright star from a really bright star.
That could be Jupiter. That's just outside the field of view.
Yeah. I was going to say it's an annoying next door neighbour.
So I'll start stacking here, and you can move on to another topic while I set up for this.
So what have we got? I think Andy said he's got an image of tarantula that he took from last week. If you want to get that up, Andy, if it's the one I think it is. Oh, it's ready. Here we go. This is Andy's image of tarantula from last Saturday. It's a pretty detailed image. There you go.
You can really see the spider shape in it now, can't you?
Tell you what, spiders for that big.
That is absolute astronomer humour, that one, isn't it?
Yeah, they can look that big sometimes too.
Yeah, they can.
Mark, everyone keeps telling me not to give up my night job.
What's that? Oh, of astronomy, yeah.
Yes, and
I get that one too. I get the day job one as well, yeah. Dad jokes and all. It goes hand in hand with astronomy, I think.
Yep. That was a good fun week, fun night on last Saturday on Halloween, and a lot of people got dressed up, and it was a good night.
Noel turned up as Uncle Fester. That was probably the best, I think. I feel like I let the team down. I just had an axe in my head. That was it. So while Kim's doing what he's doing, we might. Jen, have you continued to stack your images of Helix? She's on. Hang on, I've got to unmute you.
No.
There we go.
I'm up to my 8th frame.
Oh, and is it live stacking?
Yeah. No, it doesn't stack live. No.
Oh, okay. So you still got the same frame going.
Yeah.
We might just quickly jump back to that for a moment while Kim does what he needs to do. So this is our glorious Helix Nebula. And unfortunately, I think Noel and Andy are clouded out, and I think Paul mentioned he was clouded out as well.
Oh, wow.
So we're relying on yourself and Kim at the moment to bring us some images.
Okay.
There we go. So try and bring that back to where I am. I lost you guys for a second there.
Is it possible to enlarge that image? I'm not sure whether you can do it or Jen has to do it. Mark.
Jen will have to do that, yeah.
Yeah.
So you're zooming in there, I think.
Yep. One of the things about the tarantula, about the Helix Nebula, is if you've got a large enough telescope, or you take a long enough exposure, or do enough stacks, you can make out some fainter, more distant objects, usually galaxies, behind those wisps of gas.
Wow. That's there you go. There's another new thing on.
Yeah, there are quite a lot there.
Yeah, that's something new I've learned, that's for sure. Wonderful fact. Very interesting fact. I like that one. Now, Jen, there's your challenge. Stack, 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 and stack, and find those galaxies.
Thanks. I'll try.
I'll tell you where a couple of them are, Jen. If you can imagine the Helix as we're looking at it right now as, let's say, an Aussie rules oval. Do you know where the goalposts would be at either end? That's where you have to look.
Okay.
Yep.
Challenge is being thrown down. So just quickly, I just noticed a comment which pretty much sums up 2020 in the life of Pluto from Lee. From planet to dwarf planet to pixel, 2020 has been terrible for everyone, even our favourite distant neighbours. we have relegated Pluto to a pixel. You poor little thing.
Could have been worse. Could have been worse. Just a dog.
Could have been just a dog, yes. So, Andy, I think you've got a star trail here for us to have a peek at. Where did you take this one?
Yeah, right next to my little tent. I've got a water tank there. Yeah, it's just pretty well turned around and looking south. I'm just trying to find a single image of that. Got it somewhere. No, right at the moment I cannot find it. Of course. Star Trails. Here we go.
While you're looking for it, Andy,
Yeah.
maybe somebody would like to explain what we're actually looking at.
Okay, that's an image. It was probably about an hour and 20 minutes, 30-second exposures. I'm looking at the South Celestial Pole, which is right in the middle. And because the sky rotates around that, that's why the stars are streaking. They're becoming trails. And then I've stacked all these on top of each other, but kept the foreground static.
It's a nice image, that's for sure. So just quickly, Paul has graciously gone and dug up his lazy 111-hour Helix Nebula.
Whoa!
Could have taken some more time. Could have put some more effort into that one, Paul. That's
I think so too, Paul.
Yeah,
It looks like 110 hours to me.
Yeah. Wow.
Some interesting things here, like can you see my cursor at all? Can you see that?
Yeah.
My cursor? Right. So these outer chevrons here, they're part of the original, the very first outbursts. And there's actually another chevron here that's very, very faint. Lots of galaxies in this field here. But also down here, there's some like a really long chevron coming out. And with more time, you get this data that starts to produce and show itself. This also contains hydrogen alpha, so you can see the striations coming out from the core there. So that's why people say it looks like the eye of God. You know, it does really look like an eye. You know, even to the point where up here and around here might be the eyelids.
It's a beautiful image. So much detail in.
Yep, it is. And the Progenitor Star now looks dead set in the middle of the pupil.
The colour of it is the blue of it.
Yeah, it's a spectacular object. It really is. Even visually, it's quite interesting to look at. Just for the galaxies, there's a galaxy off to the left here, just a small one of the ones that Perry mentioned.
Can you zoom in on that one, Paul? Because you can just make that out now that you've pointed it.
Yeah, I can't go any. Oh, hang on, I'll try. Let's see what I can do here. Let's have a look. There you go. Go a little bit bigger.
Yeah,
so there's the galaxy there. There's another one there. Another one here.
There's one over there too.
There's quite a few, isn't there?
There are quite a few in this field. Yeah. There's another nice galaxy up here.
Fuzzy there. Wow. Very impressive. I think I just saw another one down the bottom there as well.
Oh, let's see. This one here, yes. Yeah. And this one here. Another small fuzzy there. Bit redshifted, these ones. One there.
Yep. I'm so grateful to you, Paul, for that, because I was just making that stuff up.
Don't you make everything up, Perry?
Yeah, I do. Usually people don't challenge me. That's
well, it's just as well that you were right.
Yes.
You were not left found wanting, that's for sure.
No. Anyway, I thought you might like to see that with mega hours.
That's absolutely beautiful. I think Kimmy, you're still stacking. You're taking your images, aren't you?
I decided to stop after 31 images. I mean, they're 31 10-second images. You can bring it up on the screen if you like.
And I think what we might...
I'm sure there's a special prize for someone who can find that.
Right now.
But I...
yeah.
Yeah, I thought so. It's that pixel right there, right?
The one there towards the...
So, so I'm sure it's in there somewhere, more or less in the centre. But I'll take another image tomorrow night and somehow stack them. And
so I think tomorrow night we're not going to have the cloud issues we've had tonight, that's for sure. So tomorrow night looks like everyone's going to have clear skies, which will be very good. And we'll be able to move through quite a lot more objects than what we've been able to get through tonight, with everybody dealing with clouds in the southern and eastern states here. So I think might be worth sort of just winding it up for the evening and saving our energy for the clear skies tomorrow night. We've got tomorrow morning, Paul, at 11 o'clock, Paul will be presenting his doing a presentation on planetary imaging and processing. We'll be following that at 12:30 with a talk from Andy Campbell on astrophotography processing. So stick around for both of those as well. And I think from memory, at 2 o'clock, we're going to do some solar observing with Russell. So really looking forward to that, because Russell's energy is completely infectious, and it's always good to look at the sun. And I believe there is still some active spots on the sun at the moment. I took some images with my phone and telescope last week.
Mark, can I just pick you up on something?
Yeah.
Not so good to look at the sun without the right filters.
True. I should clarify that I have a special filter on the end of my of the 8-inch Dobsonian I use. So, and I always take the viewfinder off when I do it as well, or cover it up completely with a cloth so that there's no sunlight coming through that, because you don't want to accidentally look through that either.
Well, not only that, but if you've got a finder scope, the sun will burn the crosshairs in it if you take the cap off, because the sunlight is so intense, you'll have to get some new crosshairs.
That's why I just take it off completely.
Yeah.
And then I think following that we've got Q&A, or I'll probably get it wrong. Noel will pick me up on it. I believe it's Q&A. Quiz. It's a quiz, isn't it? It's a quiz first with Fraser, and then the Q&A after that. And so if you've got questions about space and astronomy or anything to do with those topics, you'll be able to ask those questions direct during the Q&A session tomorrow, late afternoon, early evening. And we're finishing off with another Sky for the Night with Perry tomorrow night, leading into Deep Sky. And Deep Sky tomorrow night, we're going to have wonderful clear skies, so we'll be able to look at planets live. We'll be able to look at some more deep sky objects, maybe some galaxies as well. I think Kim's just got another helix he'd like to quickly show us before we finish. So we'll finish on a live stack of helix that Kim's been working on right now. Let's add that to the stream. There we go.
Oh, look at that.
So I think that's just the first image, and it's obviously trailed. So I better put the guide on.
A little bit of
I'll play around with that. Yeah, I'll jump that one. All right, there you go.
That's pretty good from the city. That's a really faint object. So it's good from the city.
Yeah. I'll just get the guiding going. Oh, that's going.
Adelaide's not a city; it's a country town, isn't it?
We have 1.3 million people here now.
That's a big country town.
If Adelaide was put in the place of England, it'd be the second largest city in England.
Someone can prepare tonight.
I've heard this argument before from our Eastern friends.
Not from all of us, Paul. Just Mark. If you're going to rubbish anyone, rubbish Mark. Leave the rest of us out of it. We've got nothing to do with it. You're on your own, Mark.
That's all right. The only reason is because Carlton can't beat Port Adelaide or Adelaide.
No, that's true.
Guys, let's forget.
Hey guys, I'm
let's forget.
impartial.
Oh,
I'm right in
yeah.
the middle. I'm right on the border.
I just want.
Yeah.
Excuse me.
Go,
I'm trying to say
Joe. Go, Joe.
I just was wanting to point out that Kim was only probably, how many, Kim? 4 or 5 kilometres from the city centre?
Pretty
Yeah,
close.
that's right. About 4 or 5, and 15 metres from an LED street light, mate.
That's a pretty impressive image considering what you're dealing with there.
Yeah. That's excellent.
It is. So,
And it's getting bright. You can see it's getting brighter.
It is.
Yeah.
Each stack is getting better and better and better.
Yeah.
How long are your little exposures there? How long are you doing?
30 seconds at the moment.
30 seconds, yeah, and it's just going to keep getting better each time. So the other thing that we should mention, and we mentioned it earlier, I'll mention it again now, is the raffles, which will be drawn tomorrow evening. We'll draw those during the Deep Sky section. So if you haven't bought a raffle ticket yet, be sure to jump onto either the ASSA or ASV Facebook. The posts are up there with the links through to the raffles. $5 a ticket. All the money raised goes to both of our non-profit societies. The ASV's fundraising portion will go to our Pathways to the Planets project. But once again, thank you everybody for coming along. And Kim, thank you for letting us finish with a live stack of Helix Nebula. If you're going to keep doing that one, can you show us the end result tomorrow night?
Yeah, I might let it run for a while. Actually, I'll just set it up properly. I've put the wrong darks and biases on it, but anyhow, I'll reset it.
Fix it in post. Is that what they say?
No, this is like EAA. I mean, I don't want to process this afterwards. I just want to do it live.
Do it live,
So
yeah. It's
my idea
looking
is
good.
not to do post-processing.
Beautiful. Thank you very much. And thank you, everybody, for jumping on and lending your expertise tonight. It's been great. So we'll say goodbye for now.
Everybody
I must
tomorrow.
say, just before we do go,
Yep.
this is really what actually happens at VicSouth. It's like being with old friends, seeing Joe and Kim and Paul, and Jen's been at VicSouth. I'm not sure if I met Andy at VicSouth, but it is just like being out on the field at the little desert nature lodge, or having dinner with everybody and shooting the breeze. So good to see you all, guys, and I'll look forward to seeing you again tomorrow night.
There's only one thing missing, Perry. Jen's 80s rock ballads blasting in the background.
Yes, Prince in particular.
And not emu present left behind.
Yeah, there's no dodging emu presents either, isn't there? That is the other one. So we'll see you guys tomorrow morning, bright and early, 11 a.m. Melbourne time, 10:30 a.m. Adelaide time for Paul's planetary processing, and continue it on. Thanks for joining us. We'll see you later.
Everybody.